Hello, I am Arnaud Blouin from University of Rennes, and I will present Interacto, a modern user interaction processing model we published the last year at the Transactions on Software Engineering. So we interact with software systems to control them, to modify data, to access data, and all the user interactions that provide the software system form a kind of dialect between the users and the system under control. And the goal of this dialect is to give orders, to command the system. And user interactions are complex objects. They are designed by HCI designer, they are coded by software engineers, so very different jobs. And a user interaction is composed of a sequence of events. For example, the swipe starts with a touch start, then we have a sequence of touch moves, and finally a touch ends. In fact, the swipe is a kind of drag and drop with specific parameters, such as the direction and the speed. And we do interact with software system to perform user actions on it, to give it a command to execute. Currently, the software industry focuses on user interface event to develop the interactive part of software user interface. We have atomic events such as the touch start. We have composed events such as the click which is in fact a user interaction composed of mouse down and then a mouse up. But for simplicity, we consider a click as a single event. We have widget events, which are in fact not very related to user interaction, because never mind you use a touchscreen, a mouse, or keyboard to trigger a button. And we have libraries, of course, such as particular Angular material, AmaJS, that provide more complex user interactions. Developers can process those user interface events using particular listeners or reactive programming libraries such as RxJS. But relying on user interface event faces several limits. For example, this JavaScript code depicts the use of a drag lock to move an object. So drag lock is a special kind of drag and drop. You start by double-clicking, you move the mouse, and then at the end you end by double-clicking again on the target position. So here we register to the double-click event, and at the first double-click we change the cursor, then we register to mouse move event. Then the user can move the mouse so that it moves the object. This is somehow the command to execute. And at the second double click, the cursor is set back, and we remove the mouse move listener. And that's only if the primary button of the mouse is used. So we can see that in the same code, we have the definition of this more or less complex user interaction. We have the creation and the execution of the command. We have some parameters, some optimization, and some feedback in the same block of code. So this can lead to spaghetti code. The use of user interface event also lacks advanced features, such as there is no tangible, no customizable undo-redo mechanism. There is no native user interface logging mechanism, and you have to do optimization by hand, such as throttling. So if we try to forget about user interface event and think about what developers should focus on, maybe developers should focus on selecting the right user interaction they want, parameterize it, and specify how the execution of this user interaction can create command instances that are possibly undoable. Using the previous example, we can write it in pseudocode like this. I want to use a drag lock on the interactive object node to move it, to translate it, so to create and execute a translate command. When the drag lock starts, I want to change the cursor as a feedback object. When the interaction stops or when it is cancelled, I want to set back the cursor. When during the execution of the drag lock, I want to update the translation vector. And that only if the user uses the primary button of the mouse. So here, no more user interface event, user interaction, and command. This is globally how Interacto works. Developers think about user interaction and how the execution of such user interaction can produce instances of commands, possibly undoable. This is what we call an Interactor binding, which has, by the way, nothing to do with data binding. So developers do not handle user interface event anymore, but high-level user interactions. Interactor bindings are stored in one Interactor context that also provides one undo-redo history, and developers can select the undo-redo algorithm they want. Using the previous example in Interacto, this gives the following code. So we start with the Interacto context, and we can see there is a Fluent API used to configure the Interacto binding. So this Fluent API, we call it Interacto binder. And we start by initiating the binder. So by selecting the interaction we want, then we specify that this interaction will operate on the children of the canvas dynamically, and we want it will produce this command, etc. In Interacto, the major concept is user interaction. We separate it into two parts. Behavior and data. Data refer to information related to the ongoing interaction, and this separation is useful to form families of user interaction. For example, with the family of drag and drop, in this family we have the drag lock, the classical drag and drop, the drag and pick, but also the swipe as well, and all these interactions behave differently, but in fact they handle the same data. So this allows interaction substitution, as we will see in the next slide. Regarding the behavior, we can use state machine, Petrinet, listener, or reactive programming, but currently we use concurrent and composite finished test machine. For example, here this picture depicts such finished state machine. We have a first transition, which is in fact a reference to another user interaction. This is why it is a sub composite finished state machine, because the double click is another interaction. We have move transition, etc., and we can cancel the interaction using the key escape, for example. Interaction data differ from user interface event data as they contain additional data. For example, the drag and drop contains the velocity of the drag and drop and the difference between the source and the target position. Something important to understand is that developers handle only interaction data, never interaction behavior. For example, in this routine to produce that configures how to create the command, I refers to the ongoing interaction data, not the behavior, the data of the user interaction, which is immutable here. Something important as well is interaction substitution. For example, here the user replaces the drag lock by another drag and drop, which is a reciprocal drag and drop. And we can see that all the binder still compiles, because the drag lock and the reciprocal drag and drop are part of the same family of user interaction. They share the same interaction data, so that we can replace one by the other one. By the way, the reciprocal drag and drop is a special kind of drag and drop. When you hold a position, there is a red circle that appears, and if you release on the red circle, it cancels the drag and drop. It's in fact a kind of usable drag and drop. The other major concept in Interacto is command, which are objects. This is the example of the translate command of the previous example, where developers specify how to execute the command in it. Developers never call explicitly the method of the command. This is done by the Interactor Binding during the execution of the user interaction. Developers can also specify async execution of the command. And if the command is undoable, developers have to code the undo-redo operation within the command. They can also create a memento to revert the command. And once executed, an undoable command is saved automatically in the undo-redo of the current Interactor context. Regarding undo-redo algorithm, you can have several algorithms per application. For example, in this tab, we have a text field with a classical undo-redo, linear undo-redo algorithm, and then in this tab we have another history of a different type. It's a tree-based undo-redo history. So there is a first branch, we go back at the first command, and then we start another branch of editing operations. Then we go at the first command, we start another branch, and then we can navigate in the whole undo-redo history. Regarding the Fluent API, we call Interactor Binder. Something important to understand is that in Interacto, an interaction has 4 states: started, updated, ended, and cancelled. And they correspond to specific routines in the Interactor Binder. For example, when the drag lock starts, the routine first is called, where C refers to the ongoing command created by the toProduce routine. I refers to the ongoing interaction data. And all those routines, first, then, etc., are called only if the when routines return true. We can have several when routines, they are cumulative. During the execution of the drag and drop, so when the drag and drop is updated, the then routine is called to, for example, update the command. And when the drag lock stops or is cancelled, the routine end or cancel is called. We have also routines end, routines cancelled. And we have multiple other routines, such as on and on dynamic to register to widgets, the log to log user interface information, catch to manage error, throttle to do some optimization, etc. We implemented Interacto in 2 languages, TypeScript with a binding to Angular, and in Java and JavaFX. The current focus is on TypeScript and Angular. This is several examples of Angular integration. For example, in the first example, we tagged a button with directive undo, so that Interacto manages automatically this button as the undo button. Same thing for the redo. In the second example, we rely on the Angular dependency injection for injecting in components the ongoing undo-redo histories, Interacto context, and developers can select the undo-redo algorithm they want. And is in this example, in the HTML file, developer can select the user interaction they want to then specify the method to be called to end the configuration of the binding. So regarding the evaluation, the first question was, does Interacto scale? So we use Interacto since 2013 to develop a highly interactive application called LaTeX, which is a drawing application. This application contains more than 200 Interacto bindings, so interactions. LaTeX uses almost 40 different kinds of user interaction. And regarding the performance, we used a subset of the LaTeX test suite, in fact, the user interface test suite of LaTeX to evaluate the performance. So we implemented LaTeX using callback JavaFX callback only, and we compare the execution times of Interacto and JavaFX callbacks only, and we noticed no performance override. Second point is Interacto usable. So we conducted an empirical study with 44 master students to perform 3 representative user interaction development tasks. The first question was, does the use of Interacto improve the correctness? Does the use of Interacto reduce the time? And to what extent the student prefer using Interacto? First point, Interacto is statistically beneficial in terms of time and correctness to add undo-redo features. Second point, the use of predefined user interactions is also beneficial in terms of time and correctness. But last point, we may have an interest barrier to correctly use Interacto, because we must understand how to use the Fluent API, we must read and understand the documentation, and in particular, students must master our function. To conclude, we will work on coding user interaction, because currently we think it's not easy for HEI designer to develop user interaction. So we will try to see how to ease such a task in a prototyping, in a design purpose. Second point, we will investigate if we can develop predefined Interacto binder for standard commands. For example, in Angular materials, we have a drag and drop of items between lists. This is something we may try to do later, and we may investigate whether we can use LaTeX in a virtual reality application. Okay, that's it. Thank you.